a list of things that you all said to do for a review today. So let's just spend the next like hour and a half, 2 hours going over this. If you want to do some more at 2, we can do some more at 2. So we want to go over sort of looping, right? Like what's the long way doing with just a for loop? Let's look at forEach, map, filter, and reduce again, how they work, what they do. There's also algorithm and translating, and then WTF with Codewars, classes of passing data, and structure of the code. So I think I'm almost going to go through it this way. I think this is a pretty good linearization. But I think what we'll do is we'll do it in the context of doing it with a code war. So I think what we'll do is I will do one of the code wars and show you how I would approach it, how I would break the problem down, how I might start with the code in a very long way, and then iterate that towards using some of these features like forEach, map, filter, and reduce. So you can kind of see the process, right? And then like my goal for you is like, if I go too fast at any one particular time, you're like, hey, wait a minute, like, I think you skipped a step, or like you jumped over something. Like just say like, whoa, right, and we'll go back over it, right? Because I kind of like, I try and look at your faces to see like, okay, who's following me, who's lost, right, and repeat. But I think today's a good day to like just call out like, no shame, like I didn't understand that, say it again, repeat it, right? Because we're just gonna like go through. So I think we will try, let's try this, the hardest one on the list, right? So did anybody try count of positives, sums of negatives yet? Okay,
That's
cool.
The last one?
It's the last one on that
list.
list.
I'm on right now. So
okay.
Pull that up.
Yeah, so if you'll like, you're welcome to go along, right? You're welcome to take notes. I will. Hey, look, there's my Ruby one that I did
Is this
so long ago. It's being recorded.
Right.
So let's talk about Codewars and looking at Codewars and understanding problems, because like this is kind of the fundamental thing. It's the same process I would go through with this that I would go through on a homework, right? I would read the homework and try and understand it. I would then make my algorithm. I would then write some code, get some things to work, and you'll see kind of going step by step, right? And you'll find that when I'm doing these things, I'm trying to take very small steps. The challenge for me or Jason or Mark is the size step that we can take in one leap, right, is like 20 of your steps, right? So I'm going to try and get into the mind space of like trying to take a small step on your level of steps. What you'll find is you'll think these steps are like really ridiculous. Like, why am I taking these itty bitty little tiny steps, right? Because that's kind of like the amount that you can chew at once at this point is about that level. When you get to the point where like, boy, I can knock these like 8-level problems on Codewars out, it means that you can probably think through the entire problem in your head, make the algorithm in your head, write the code in your head, and then work on it, right? Then you're going to move to a 7. You're like, oh, I got knocked back down again. I got to go back to small steps. That still happens to me when I'm working on code, right? If I'm working on an app that I'm helping develop for here, or I'm helping somebody out, or when I was working before I came back to Suncoast, I would try and take big steps, and what would happen is I would run into the buzzsaw. Like, oh, that didn't work, right? I got an error, or I got the wrong output, or something happened. My personal practice is I stop, and I go back, and I try and take that problem and break it down into 2 problems. So if you can take any particular problem you're faced and break it down into 2 problems, and you can kind of ignore the second half of the problem and focus on the first half of the problem and break that one down into 2 parts, and forget the second half and focus on the first half and break that down into 2 parts, eventually you'll have itty bitty tiny little problems you solve, and you'll just be solving them kind of in a row. And that's really the process that we're going through when we do this. If you read and reread and kind of follow that PDAC process, that's probably the best written description I've seen of this mental process of taking problems and breaking them down. So kind of think of that as you watch what we're doing here and see what's going on. So I think it always kind of starts with the reading of the problem. So, and sometimes like the description gives us a hint, like, so count of positives, sums of negatives. So when I read that description, my brain is already thinking there's two things to do here, right? The two things we're going to do are count positives and sum negatives. So my brain is already thinking, oh, awesome, there's two problems here. Counting positives and summing negatives. So if I already take one problem and break it down into two, right, I made my work easy right from the jump. Cool. So I already see two problems we have to solve. So the instructions say we're given an array of integers. Cool. So let me go look at the code. Hey, I see a thing that's given. So given is another word for input. It's another word for these are going to be your arguments, right? If I'm given an array of integers, in JavaScript, I'm given things as arguments. So I see given an array of integers. I look over at my code sample they've given me, right? And I see input. If I were writing this code, right, my brain would be thinking, aha, I'm going to have an argument that is an array of integers. We're going to return an array. Okay, cool. That's what this program needs to return. It's going to be an array where the first element is the count of positive numbers and the second element is the sum of negative numbers. If the input array is empty or null, return an empty array. And then they give you some examples of like what those look like, right? A lot of times Codewars will write these problems generically, right? And then a person will translate it into 4 or 5 different languages. So like, ignore the ones that don't apply to you. So they're showing you for JavaScript, this is what an empty array looks like. Attention, the passed array should not be changed. So the input, we cannot modify that array. So we can't add things to it or delete things from it. We need to leave that array alone. And then they give us an example. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a whole bunch of negatives. We would return 10, right? Because we had 10 positive numbers and minus 65, because that must be the sum of those. So like I might do minus 11 plus minus 12 plus minus 13 plus minus 14 plus minus 15. Sure enough, that's minus 65. I will check to make sure my understanding of the inputs and the outputs.
That works too if you just take out the plus signs.
Yeah, I could just do minus 11, minus 12, minus 13, minus 14, minus 15 would be the same thing. Cool. So there's the problem. I'm going to start to try and break this down. So I said I already see two things I need to do. I need to count the positive integers, let's call them numbers. And I need to sum the negative numbers. Cool. So we're breaking the problem down. So I look at these two and say, does one of these depend on the other? Could I do one of these without doing the other? Yeah, I think they're kind of independent. I could count the positive numbers, right? And I could also sum the negative numbers. Those are two independent things. So now I have two problems. I have problem 1 and I have problem 2. And then I return an array with the answer from problem 1 and the answer from problem 2. Right. Cool. So I already have this broken down into two parts. So let's break this one down. Count the positive numbers. So here's where I will sit down and think about how I would do this as a human being.
You break it into 2 arrays and
yeah, so that's already too far down the road. That's already too big of a step. So it's honestly, the thinking process is like this. Okay, if I were and the way I like to think about it is, what would happen if I gave you a stack of cards where on each card there was either a positive number or a negative number, but I gave you 1 billion of them? How would you process that? So when I'm thinking through these, I try and think of like my mind can look at this and go, oh, it's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? But when you try and think of in your own brain like a physical process, like think, how would I do it if there was a trillion stack of cards, each one of these having numbers? So that's why we have to like come up with very distinct steps. So the distinct steps might be, okay, well, if I had a stack of 1 billion cards, and each card either had a positive number or a negative number on it, and I wanted to count how many there were, maybe what I would do is I would take the first card off of the stack of 1 billion cards, look at it and say, if this is a positive number, I'm going to add 1 to some counter, and then throw that card away. And then take the next card and look at it, and if that card is a positive number, I'll add 1 to my counter and throw it away. And I'll keep doing that until I run out of cards in my stack or inputs in my list. When I'm done, that counter that I was keeping, that's my answer. All right, so that's I'm going through that thinking process in my head, saying, does that seem like that would work? Yeah, it seems like that would work. So maybe what we say is something like, go through each number 1 at a time. If that number is positive, add 1 to a counter. If that number is not positive, ignore it. Keep going until we run out of numbers. Our answer is that counter. And maybe I'll add a step at the beginning that says start the counter at 0. So this is almost a level that for something like this, you should be targeting. Maybe about this level of depth, right? So I feel like this level here is to the point where I could give this instruction to somebody else, and they could implement this as code. They could implement it as a human being, right? I could give a small child that knows like what some of these terms mean, and like do this process without asking me any more questions. Right? If we start going through this and we run into an issue, what do? We come back to this list and we break each one of these down a little further. Right? So maybe go through each number 1 at a time. Maybe that's not detailed enough. We'll find out. Right? If that number is positive, add to a counter. If that's not detailed enough, we come back and we break it down. But when you get to the point where like, oh, I kind of feel like that's enough, let's see if we can start turning this into code. So let's take this down here into our function, right? Because this is where we have to implement it. And I'm just going to start trying to translate these things into JavaScript. Hey, start a counter at 0. That sounds like making a variable that's equal to 0. Go through each number 1 at a time. Yeah, it sounds like a for loop. So if you can think of the for loop here clearly, let's write the for loop. If not, then we have to break this one down into the components of a for loop. So to break that down, we would say something like start an index at 0. The number to work with is the element at position index. Right? Use that number. When done with the number, increment the index by 1. See if we went past the end of the array. If so, stop. Otherwise, go back to the step, use that number. Right? That's the breakdown of go through each number 1 at a time to that level of detail. Right? So at some point, you're going to see something like go through all the numbers 1 at a time, and your brain's going to be like, boom, that's a for loop. I know how to write a for loop. I'm done. If you're like, oh, I can't remember how to write a for loop, right? You work on trying to break down that step into little details, right? And what you'll find is this, all of these parts become our for let index equal to 0. Right? That's this. Right? We're going to have something here and something here. right? It says the number to work with is the element at position index. So element equals the element at position index. So we know we're going to have index, and our array is called input.
Why'd you skip the rest of the order?
Because I'm not onto those instructions yet. I'm going through these one at a time. I'm going to go through my steps one at a time. So now it says when done with increment the index by 1. That's the post part. Index plus plus or index plus equals 1.
What's it called? The incrementer?
The incrementer, right? So this is the initializer. This is the code inside the braces. This is the code inside the braces. Inside, right? This is the incrementer. This is the comparison. Cool. So now I've written this part. I've written this part, right? So now the comparison is keep going as long as index is less than the input length. That's how we know if we've gone past the end of the array. Now, what I'm lacking is the use the number part. Right? That's where this code expands. Right? So that's this bit. Right? So I'll just move my comments into here. Now, all of this is inside of the going through the numbers one at a time. If that number is positive, right, so how do we say a number is positive?
More than 0.
Yeah, if it's more than 0. Add 1 to a counter. Plus or counters plus equals 1. If that number is not positive, ignore it. Well, this might be
plus equals 1.
plus can only be used to add one number. If you need to add a number by 2 or 3 or 4, you do plus equals 1. So this just adds 1. So the if that number is not positive would be our else, and it says ignore it. So that would tell me that we don't need the else.
Another if statement.
Yeah, I mean we could have another if statement if element is less than or equal to 0. Right? What did our instructions say to do? To ignore it. So when we ignore something in code, that just becomes nothing, right? If the case that is not positive, there's nothing to do. So I would not include this if statement.
Should we make that if statement the one that adds it up then?
Maybe, but we've broken the problem down into 2. So what we want to avoid is thinking ahead. The death to a programmer is thinking ahead, right? It seems weird, like, oh, but I'm in this thing and I could do this because I know the second part has this, right? At some point, you're going to be able to merge problems and think ahead and merge things together. In the beginning, right? Slow is smooth, smooth is fast. So maybe in the end, we're going to combine these into one loop. But for now, we decided we were breaking the problem down into smaller pieces. So we're going to hold off on that, right? Keep going until we run out of numbers. We've got that. And our answer is the counter, right? So this stuff, we decided we're not going to ignore it. This is handled by the go through the loop. And our answer is the counter. So let's indent this stuff properly, right? And our answer is the counter, right? What did we say it's going to return? It's going to return the answer, an array with an answer from problem 1. An array. Where's our answer from part 1 of the problem currently? Counter. So let me run the sample test and see what we get. Oh, look at all. Wow, that really sucked. It just tells me I have the wrong return value. It doesn't even tell me if I got half the problem right. You jerk.
Tell me about it.
Right? So let's console log the input. And let's console log our counter. And let's see if we think we got the answers right. So let's manually go through and count these. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10. 1, 2, 3, 4, 5, 6, 7, 8. 8. To me, this looks like the first half of the problem is complete.
The let element equal input index. Why did you have to create another variable element there?
I don't.
Okay.
The only reason I did it is because my long written out instructions said I should do it. So the idea is I'm going to follow very pedantically, very detailed, very word by word what my instructions in English said, even if it means writing more code. When I'm done and I have the right answer, and I know my answer is correct, I can go back and change my code as long as I think it's correct. So yes, I validated that my answer is correct. Now I can go back and refactor the code a little bit and then see if my answer is still correct. I should get 10 and 8. Cool, I do. Right? As long as I have a check that my code is correct, I can start changing it. I stop that process when I break the code. But having these checks tells me, hey, as long as you change the code and these tests still pass, right, we're on the right track. So maybe that's as much refactoring as I'm going to do now. Right?
Just deleting the let element part.
Yeah, I got rid of assigning this to a variable, because we know the rules. Like if you just assign something to a variable and you just use that variable, you don't need the variable. You can just replace what you assigned it to the place where you used it. Right?
Okay.
Instead of assigning this to a variable and just using it, this element is this input index. So I can just move that here and get rid of the variable. Now, if I use that variable 2 or 3 times, it might be better to give it a name, right? So if I had something like let element equals this, and then, right, if I also had like if element, maybe the rule is like if the element is a 7, right, do something else, right? Counter plus equals 42. Let's say the rules were this. Maybe I wouldn't do this refactoring because right now this is a little bit more confusing. Right, because now I'm using that variable in 2 places. So in this case, I wouldn't do this necessarily. I would still do this.
So if you hit 7 on the index, you're going to add 42 right now.
Yeah. I'm just giving the example. What would happen if I was using this variable more than one time? Would I do that reduction in code? Probably not. But since it's only used one time, then yeah, this reduction in code is okay. But if I was using that variable 3, 4, 5 times inside of this loop, maybe I wouldn't do that reduction. Let's tackle the second half. So the second half of the problem says sum the negative numbers. So let's do the same thing. Let's go through each number one at a time. Let's start a sum at 0. All right, so now we're going to say is if that number is negative, add the number to our sum. If that number is not negative, do nothing.
I don't know how you
Ignore it.
break the problem down to so many details. I don't know.
Practice, 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 practice. Literally, when you break your problem down, like when you get one of these Codewars and you break the problem down, however many steps you have, I guarantee you should double it. Each one of those steps should be more steps. You have to take each one of those steps and break that down into more steps. The practice is in refining your thinking to break things down into little steps. The activity we're going to do on Friday is going to reinforce this for you, right? Because this part I'm doing right now is what you will be paid to do. It is not typing the code. It is not understanding that an argument gets passed to a thing, right? That is all of the details, right? Anybody here ever worked as a chef? Anybody have any chef experience? Cooking experience, right? Yeah, so you like to cook, right? So, like, nobody cares, like, how good your knife skills are when they eat your meal, right? Like, I can't tell how good you are at, like, your knife skills when I'm eating your food, right? What I'm paying you for is your ability to make a delicious meal. And you do that by understanding the ingredients and flavors that go together, right? That's this part, right? That's what we're doing here. We're doing that part of being a cook, right? what you're paying to do is take problems and break them down into smaller problems that are easier to solve. Right? You're going to get handed a giant problem. Implement this thing. Okay. And your boss will be like, I don't know how to do it. That's what I'm paying you to do. Right? Or maybe they do. Right? Maybe they know how to take the big problem and break it down into 2 pieces. And maybe they know how to take each of those pieces and break that down into 2 pieces, and then they're done. They're like, I haven't thought about it past there. Like, it's your job to go finish that. Right? But like the knife skills and those sort of things are the like making a class and organizing my code, right? How clean you keep your countertop while you're cooking is like how nicely you keep your code indented, right? Or like how good your variable names are, right? You can have a good program that comes out the other side, like with terrible variable names and the code's not organized and all that, right? But the program's still going to work, right? The meal's still going to be good, right? What you actually get paid for is understanding flavors as a chef and how they blend together. What you get paid for as a programmer is how to take problems and break them down. The code is just the ancillary part that happens because you have to do that, right? You have to be able to dice an onion, right, a certain way. You got to be able to organize your JavaScript code a certain way, right? Notice like none of this yet has anything to script. I could take this same thing and code it in PHP, Haskell, Ruby, C, C++, right? Differs. This is what we get paid to do. The more we dive into this, right, the easier the code's going to be to write, right? The better you get at this, the easier these Codewars kinds of things get. The more when you get to a coding interview or like day one in your job and someone's like, hey, go add that button to that page. Okay, can I add a button to the page? Okay, how am I going to break that down? Okay, what do I got to do first? I got to go find where the frick that page is, right? Where do I find that in the code? How do I, right? You're breaking problems down. That's the whole part. So we do this simply by practicing it, right? There's no way to say, here's a recipe to follow for breaking every problem down, just like there's no one recipe for cooking every meal, right? So that's why I say like that PDAC process is the best general guide to how do you think about this in terms of building these habits, right? And this is why we give you these Codewars, is to start building this like muscle memory to the point where yes, you'll be able to like dice an onion like without thinking about it, like you'll just be able to do it, right? The only way to achieve that is by doing these practices, right, and going through this level of detail, right? I can tell you that I can solve this problem. I could just read the problem and write the code directly, right? I don't even have to think about it at this point. But I've been doing this for 40 years, right? Right? After a year, you should be able to look at these and be like, bam, I can just, here's the code, I know how to do it, because you've done it dozens of times. You've done counting things 100 times. You've done summing things 100 times. You've used forEach loops 100 times, right? And then you're gonna walk into like, let's say you all keep doing JavaScript, right? Then you're like, hey, cool. Our job is switching to this language called Kotlin, which is a derivative of Java. What? Okay, cool. Let me go learn how forEach loops work in that language. How do you iterate over things in that language? And you're gonna go back to a level 8 Codewar and be like, okay, I know I do this in JavaScript. Okay, I got to do a loop. Okay, how do I do a loop in this language? Right. And that second learning process will be faster. Once you've kind of got this muscle memory for breaking down problems, you're going to be able to break these problems down faster. The leveling up becomes you're now able to break down bigger problems faster. Right? So at this point, we're literally breaking these things down into tiny steps that seem really small. Then these things will just become a muscle that you have that you just do. Now you get to tackle bigger problems, and you break them down until you get to the point where you're like, that's a muscle memory. Oh, go through an array of numbers, boom, that's a forEach loop. I don't have to break that down any further because I know in my gut how to do that, right? And the challenge is like when you make that break, right? When you go to write the code and it doesn't work the first time, like the second, like you're like, what do I type here? You've got to go back and make the instructions deeper because it means you haven't built that muscle memory yet, right? That's, I think, one of the hardest things for students to like grasp on and do because like it's really tedious and it's painful, like working, this coach is making me go lift weights again, darn it, right? Like this is that part. So it just comes with
Do you
repetition.
agree the difference between a really effective coder, even if you have the same skills, but they can do this better, they're probably going to write better code?
So this is a better software developer versus a coder, right? So a good coder can take this instructions and turn it into code. You being a good software developer, software engineer, can do this part and write the code, right? So like my job as a senior developer, right? If I was your senior developer and this was a job, my job is to take the problem that the business has and break it down into small enough pieces that I can assign each of you a small piece that you are capable of doing. Then it's your responsibility to take that problem and break it down into small enough bites that you can turn that into code, right? So the more senior you become, the more you practice these things. It just means you can bite off bigger problems, right? And your most senior developer, your CTO, your lead developer, right? They're the ones that take the problem and figure out how to break just down from the business description. Like, hey, we're gonna implement the ideas for Uber. Go code Uber, right? Where do I start? Right? That's what like the CTO, senior dev.
That's what I mean.
Right.
It's not necessarily the writing of the code, it's being able to do this part that separates the difference.
Breaking problems down,
Right.
right? Literally being able to break problems down. That's what's going to help you move from where you are today to graduate, to effective on your first day of the job, to moving through being a junior, to advancing your career, to being able to work on bigger problems, is continuing practice breaking problems down, right? Because when you break them down, the code part will just be, right? It seems like impossible right now. Like, Gavin's talking crap, right? There's no way. Like, the code part will never be easy, right? But the more you break these down, the more you're going to start to see, oh, this instruction I came up with is this idea in the code. And that just happens. That just happens with practice. Okay, cool. So we're going through the numbers for the negatives. We started the sum at 0. We're going through the numbers one at a time. If that number is negative, we're adding the number to the sum. If that number is not negative, ignore it. Keep going until we run out of numbers, and our answer is that sum. Cool. Let's see if this works. Let's start a sum at 0. So somewhere in my brain or a scratch pad, I have a thing that says sum and it's 0. Go through each number one at a time. 1. Is that negative? No. Negative, no. Do nothing, do nothing, do nothing, do nothing, do nothing. Is this number negative? Yes. Add that number to the sum. So now sum is negative 11. Go to the next number. Is that number negative? Yes. Add it. Now it's negative 23. Now it's negative 36. So forth and so forth, and we end up with the negative 65. Cool, I've checked my algorithm. This part's super important too, right? The PDAT guide is going to have you work this out on paper with a couple of examples, right? Right. Maybe we should also make sure, right, that we've done this if the array is empty or null. Yeah. We'll see if the algorithm we came up with handles that. Let's find out. So let's turn this into code. So here's part 2. Start a sum at 0. Go through the numbers one at a time. Okay, well we just did that. For let index equal 0. Index is less than input. Length. Index plus plus, or plus equals 1. Cool. Let's move these statements inside. This is the work to do. If that number is negative, so let element be index, input of index. If element is less than 0, then what? Add that number to sum. Sum plus equals element. If that number is not negative, do nothing or ignore it. Well, we know to ignore those things. Keep going until we run out of numbers. We know how to do that, and our answer is that sum. So let's console log input again, and let's console log sum. We got 10 and minus 65. And here we got minus 50. Do we think that's right? Let's see. Negative 11, negative 11, 12, 13, 14, minus 50. Cool. So if that's true, then we can just... Here we're doing, at the top one, we're doing minus 11, minus 12, minus 13, minus 14, minus 15 is minus 65. And the second one just goes up to minus 14. Yeah. So let's return counter and sum. And so this is finally the last thing, right? It says to return these two. The test pass. Now we failed, right? Cannot read property length of null. If the input array is empty or null, return an empty array. So we missed this step here. So before we break down even problem 1, with problem 0, if the array is empty or null, return an empty array.
What's the difference between empty or null?
Yeah. So what they're saying is, if we look, so this is an empty array. So in JavaScript, null is a value without, is a variable without any value. So JavaScript has undefined, which means I don't know what this thing is. Null is, I know what this thing is, but there's nothing there. There's a really good example. No. Okay. 0. Yeah. Okay. So here's 0 toilet paper. Here's null toilet paper. Here's not a toilet paper, right?
That's a good answer.
Yeah. And then there's like, right. So here's 0 paper and null toilet paper, right? Like undefined would like there wouldn't even be a dispenser here. Oh, here's the paper. There's 0 toilet paper. There's null toilet paper. There's undefined toilet paper. Right?
That's fantastic.
Right. Yeah.
Why do they both return undefined now?
What is both? What is what? Richard, what?
So, yeah, go back. So when you just did the code and node.
Oh, that's because a let statement always returns undefined. A let, so empty array is this, and null array. So a let statement itself returns undefined. Right. We could also say an undefined array is undefined. Right. An undefined array stores undefined. Right. An empty array has this, and a null array has this. So in our code, we have to say if the input length is what? How do we tell if it's empty? Yeah, so we could say this, or the input equals null. What do we return? An empty array.
So you can do that, return just like that.
Return just an empty array. Yeah, you totally could. You could say, you could totally say let empty array equal this, and return an empty array. Yep. Just remember that anytime you have a variable, you can replace it with the value of that variable if you're only using it once. Cool. Let's see if our sample tests still pass. They do. Let's see if our attempt still passes. Okay, what did we miss now? Oh, now I think the problem is we're doing all this console logging. So sometimes we console log so much that Codewars gets mad at us. Because Codewars is only going to let you console log a little bit. Let's see if that's our choice. Okay. So it said down here, we expected empty, but instead we got 0 and 0. So all of these tests passed. It said we expected this, but we got 0, 0. So down here, let's console log our input and our counter. and our sum. And let's see if we can figure out what that input is doing. Our input is the empty array, but we're returning 0 and 0. So this may not be enough here to do this. So instead of saying compare it to an empty array, let's ask that the length is 0. Let's try that. Now it's saying we can't read the property length of null. Well, let's move this null check first. First, let's check to see if it's null. And if it's not, then we'll ask that for the length. So if we get a null, we want to check that first and then check, hey, this is not null. We'll check. Hey, now we're finally green, right? So Codewars is going to put some sneaky conditions behind the attempt. You just got to kind of work through what they are. Let's take our console logs out, and we're all green, right? Now breaking the problem down, right? We could submit this and be happy. Maybe we would take all of our code comments out, right? Maybe we would leave them in for ourselves. One thing I do is I keep a Git repository of all my Codewars. So I will take this entire code and copy and paste it, right? And I have on my hard drive dev Codewars, right? And I have it broken down by language, right? Haskell, JavaScript, and Ruby. So I would go into my JavaScript folder and I would make a file called count some negatives, right? I would do atom, right? And I would just paste this code in and I would save it for posterity. Because it's very hard to get your code back out of Codewars, right? And maybe you just want to make a little GitHub repository of all of your Codewars solutions. I keep them locally in Git, but I haven't pushed it to GitHub. But for y'all, I would suggest maybe push it to GitHub and just show, like, here's all the Codewars I've ever done. It also gives you the chance to, like, go back and refactor it, which is what we'll do now. So let's refactor our for loops towards using forEach. Right? So we know that forEach is a more flexible for loop, right? So the for loop is kind of involved. We have to have this index and a comparison and a counter, right? We can replace this for loop with a forEach loop. But the forEach is on the array. So array.forEach. Which array are we going to forEach? Over the input. And we know that what goes inside of here is a function. Right? We have two choices to do that. Right? We're replacing this. Right? We're getting rid of this for loop and we're doing a forEach. We can define the function out here, right? We can define the function out here, the function that takes an element, right? Right, and does the thing with thing, right? Or we can put the function right in line. Either is fine. Let's do it both ways. So the function is going to go here. Well, the function that we're doing is this, right? So the forEach goes away, and what used to be inside of the forEach comes here. But we don't know more, right? All we are now, we're past the element. The forEach loop gives us the element one at a time. Right? So the forEach loop hides all the implementation of the looping part. Right? So the for index equals 0, index less than input length, index plus 1, array index, all that goes away, and we're just given each element of the array. Right? And our code still works. Right? I got rid of the for loop in favor of a forEach loop, but now for each I have to give it the function to call for every element of the array. Right? Rather than have the brackets at the end of the forEach loop, I give it a function. That function has to have a name and an argument. We learned that there's actually 3 arguments. We could get the element and the index and the array, but all we really care about is the element. Right? The only part we need is the element. So one at a time, we're going to get each element of that array, and we ask, is that element more than 0?
So forEach is literally taking our for let index equals 0 index,
Mm-hmm.
letting all that, and just making it into forEach.
Mm-hmm.
Just saying forEach instead
Mhm.
of writing all that out.
Yes.
That's so
If-
easy.
If
to
you
understand.
go, but yes, absolutely. And if you want to see the details, go back to the lecture that where we did the Suncoast forEach, where we implemented forEach ourselves, right? It's literally just replacing that line, and it's replacing this line. Let element equal input of index. That's what forEach does. It replaces that. Oh shoot! Sorry, I hit the escape key. It replaces that with just taking a function. Right? Now the same rule applies. Here's a variable, but we're only using it here. So rather than have this variable, what some of us JavaScripters will do is just put the function right there. So that is literally the same. Right? Rather than declare the variable outside of the forEach loop, you can just drop the function definition right inside. And that is the same. Right? So forEach takes a function, well, let's just put it right inside the code. If that is like too much, right, this is totally fine. If understanding, like I make a function that takes an element, I do something with it, I pass that function to forEach, and it will do the work, awesome. Just know that pretty soon, we're going to start to get in the habit of writing it this way because other things are easier when we learn the inline way, right?
An
So-
element is a Taco Tuesday, right? Doesn't
Yeah.
matter what the hell we call it.
Yeah.
As long as if that thing that's in there is more than 0.
Yep. X and X, Taco Tuesday, whatever you like. So my preference for naming variables, and you'll see me do all this time, right? I probably would have called this input. I would have called this numbers. I like my variables that are collections of things to be plural. Because it helps me as a programmer remember this variable has a lot of stuff in it. Right? So I would have called the array, instead of input, I would have called it numbers. That also makes it really easy to decide what to call this variable. Number. It's always going to be this, in my code, it's always going to be the singular version of the plural that I use for my array. It makes naming stuff super easy. Does every programmer follow this? Nope. It's just a habit I have. Why do I have that habit? The Ruby community almost exclusively uses that habit. And I picked that up from programming Ruby, and now I use that same pattern everywhere, which is why getting exposure to new languages will make you a better programmer over time. So I had to come up with another variable name, so I'll just call it element. So let's do the same thing down to this one. Right? So, yeah. So instead of these two lines of code, we're going to have input.forEach.
Do you even need to do that again because you already couldn't you just close the
Yeah, small steps at a time, right? So I'm gonna start to refactor one bit of code at a time. So if I did a forEach there, I did a forEach here. Right? And all I've done is replace that forEach, and my code still works. Right? So now we're looking at patterns. Hey, look, we've got the same forEach loop in here twice. All right, I got a forEach loop here, and I got a forEach loop here. What if I just took this sum and move the sum up here? Would that be okay? Yep. I'm going to get rid of all these comments. Hey, look, now I have kind of the same loop here. This loop and this loop. So I don't have to do this loop twice. I could just move this code up here and get rid of that loop. And my code still works. Right? So this is one way of doing it with forEach. Right? So what's going to happen eventually is you're going to be able to look at a problem like this and say, okay, well, I'm going to go through the array and I need a counter and a sum. Input.forEach element. If the element's greater than 0, add. If the element's less than 0, add. And done. Let's try this a different way. instead of forEach, let's use filter. So remember, filter is another one of our functions that takes an input and gives us back either the same array or a smaller array based on a selection. Right? So we essentially have two different conditions. One where we're pulling out positive numbers, and one where we're pulling out negative numbers. So one way we could have done this, we could have said input filter element, and now filter needs to get back, gets back a Boolean if we are keeping this element. Right? And remember, filter, unlike forEach doesn't return anything that's useful, but filter sure does. Let's have this be the positive numbers. So filter takes a function and returns a Boolean, and it's going to give us back an array of all the elements where we decided to keep that element.
What did you define input?
Input is the input to the function.
Oh, I see.
So let's define a keep variable equal to whether or not we're going to keep this element. Right, so the comparison is still the same. And we're going to return keep. So right, filter is going to take our input and go through every element, and then our function needs to ask, are we keeping this person, this element, or are we not? So the ones we're going to keep in this case are the positive numbers. If we console.log positive numbers,
So do the same thing as forEach.
it's going to do slightly different than the forEach, right? Look what positive numbers now is. It's just the positive numbers. So forEach and filter work differently. Right? forEach goes through every element and does some work. Filter goes through every element and asks a question. Keep this element or don't keep this element. And at the end, it gives us back a new array of all the elements that we kept. Right? So filter is just like what it sounds like, right? Like your water filter, right? It lets the water through and keeps the impurities out, right? This filter allows the positive numbers through and keeps the negative ones out, making a new array.
Is keep an actual, that can be anything?
Taco Tuesday,
Okay. Just making sure.
right? It's just a variable. So much so that most of the time we don't even use it. We do this, right? Now, even better is we know that one of the rules of arrow functions is if the only thing an arrow function does is return a condition, you can get rid of the brackets and just have the condition. So our filter could look like this.
So that will still return.
Mm-hmm.
So arrow.
In the console log only.
Yeah, so all we're doing so far is console logging.
Are you finding elements somewhere before this?
I am not. Element is the argument that the function that filter takes requires. So remember, filter, I could have written this like this. Const keeper of positives equals a function element, right, that returns element, oh, come on, greater than 0. Right? And then I could have just put keeper of positives here. Positives. Right? Filter requires a function, and the contract of this function, the agreement of this function is it will take one argument, which is each element from the array. That's the rule of filter. So if you go look up the documentation for filter, filter says, yo, you better give me a function, and that function better take one argument. And the contract I have is I will keep calling your function, and I will fill that argument with successive elements of the array, one at a time.
How does
That's-
element draw data from the sample tests? Like how is
It doesn't. The element is one element at a time out of the input array. So if we look at filter, filter is going to say, hey, I'm called on an array. What array am I? Cool, I'm the input array. What do I need to do? I need to go through the input array, one element at a time, take the first element, call whatever function this guy gave me. and give that function as its argument the element. So I'm filter looks at input, right? Input's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 11, negative 12, negative 13, negative 14, negative 15. Right? Whatever the test passes us. It's going to pass us an array of some kind of numbers. We want to go through and filter them down. Filter is like a fancy forEach. It's going to go through each element of the array one at a time. It's going to grab the first element. It's going to call your function. Your function had better take one argument. And then your function should do one thing. It should return true or false. True if I'm keeping this one in the output. False if I'm not. You're following? No.
I'm not following.
This is the to say, no, Gavin, I don't follow you. This makes no sense.
Absolutely. Yeah.
So let's do it. Let's do it visually.
I don't understand where you're defining like the function keeper is a positive with the element.
Right here.
So you define that, and then but what is element?
Element is the argument.
Greater than 0.
It's the argument. Cool. Here's what we're going to do. Andrew, up. Stand here. You are a filter function. You accept an argument called element. And what you're going to decide is whether or not that element is more than 0 or not. You guys are an array. You are number 5, and you are number negative 42. I am the filter function. So when the filter function calls, I'm like, cool, I got my array. My array are these two people over here. Cool, do I have a function? Yep, I got a function over here. Does that function take an argument? It sure does. Cool, I'm all set up now. The filter function is going to go take this first number, 5, and it's going to pass it to you. Sir, here's a 5. True or false?
It's true.
True. So I'm going to take that 5, and I'm going to make a copy of them over here. So now I've got another Justin over here, right? Okay. Cool. Then filter's going to be like, cool, I'm going to move on to the next element. Negative 42. Sir, here's a negative 42. Would you like to keep this number or reject it?
Reject that.
Awesome. Throw it on the floor. Cool. Universe of JavaScript, here's your answer. It is an array of one element that just has a 5. So that's what on this page. So you on this page, on this page, Justin and Carson are input. You are the function keeper of positives. I was acting as this. So Justin and Carson were this. You were keeper of positives. I was the filter.
And where's input defined elsewhere?
Input is the input into our function, into the code we were writing.
Okay.
So input was these guys over here. They were given to us by the universe, by whoever's calling us. So the input to our function was the array of 5 and negative 42 that came into us from somewhere.
I guess what I'm asking is how does this know any of these numbers down here? Like,
Because that's what Codewars does. Codewars says, I'm going to call the code you're writing 700 times with random different input. So you are only writing this function to satisfy the requirements that the Codewars is giving us. And then Codewars is going to call your function with all kinds of different input. Empty arrays, arrays with 1,000,000 numbers, arrays with all zeros, arrays with all 2s, arrays with all 42s. You don't know. And you don't care. Because as long as you've written this function to do what Codewars says it should do, you can take any input at all. Your code can handle any input Codewars throws at you because you've written it correctly.
but it has to say input.
I could change this to say numbers, but they've told me, please write the function count positive numbers that takes one variable called input.
So
If I change input, I have to change input throughout this entire function that I've written. Right?
So it doesn't matter what that says. That just, whatever is there, since it's one thing that's there, it means this is one singular argument that this function accepts.
And it's going to be an array of numbers.
Okay.
Now, when I started writing this, I could choose to rename this variable. I cannot choose to rename this. This is dictated by Codewars. This is not dictated by Codewars. I could change it. but I decided not to confuse you any more than I needed to confuse you.
And that's because down here it says whatever count positives,
Right.
some negatives is
Yeah.
this
Yeah.
array of
Right.
Where does that function end?
It ends all the way down here. It ends all the way down here.
Should I sit back down?
Yeah, cool. Did that help? Did that make more sense?
A little.
For the record, I'm at least a 7.
Okay, cool.
Yeah, come on, negative 42. What is this?
Yeah.
And you rejected that?
Yeah, and you got rejected. Man. Right. So, just for some, so I want to show. So we know one of the rules for arrow functions. So if you're okay with this, you could ignore the next 30 seconds or a minute. One of the rules for arrow functions is with a single argument, we don't need parentheses. If your function just returns one thing, you can do this reduction. You can get rid of the brackets and the return statement and just do this. This is a valid JavaScript function. If that's true, you can just do this. So on one little tiny line of code, I have taken my input and run it through a filter, right? And said, hey, for every element, if the element's greater than 0, put the answer in positive numbers. That is a one-line filter that will just give me the positive numbers, right? Then, right, I can have another one that is input filtering the element as long as the element is less than 0. Now I have two arrays, one array of positive numbers, one array of negative numbers, right? Now here, instead of going through my input, what if I just go through my positive numbers? I no longer need to do an if statement, right? Because I know every one of these numbers is positive. Then I could for each through here, right? And do the sum, because I don't have to do any comparisons. I know every one of these numbers I want to sum.
What is the bottom one? One of those two be the negative numbers.
Oh, sorry, negative numbers. Yes, yes. Thank you. Copy pasted the wrong thing. Right, and I get the right thing. Right.
It's even easier than forEach.
That's even easier than forEach. Now I know that what I'm doing here is I am taking a big array and I'm ending up with one number. That sounds like reduce. What does reduce do? Reduce takes an array of things and gives you one thing out. So now let me try and use reduce.
Really quickly before that,
Yes.
scroll back up to element. Where it's originally, that's where it's originally shown.
Yes. Yep. So this is me compacting this down to the smallest bit of code that I can do, right? But if I go back to the version that takes a function, remember filter. The contract for you when you were behaving as the filter is you expect it to be a function that takes one argument and returns a boolean.
Like a yes or no.
A yes or no, and that's what we're saying here. This is the shortest way of writing this JavaScript. This right here is a function that accepts one argument and returns a boolean. Its element more than 0.
Is there any chance you show that with two elements, two separate argument styles?
So if it took so for instance, filter also gets the index and the array. It would look like this. But notice we're not using these two, so I don't need to declare them. So I only need to give as many arguments as I'm going to use.
If you type out in the function, would it just be the comma index is whatever, however you want to compare it?
Yeah, I mean, I can call this whatever I want. I can call this IDX, I can call this I, and I can call this A, right? You'll see,
Your function is separated by comma.
yes. And you'll see some people do this. They'll use E as the element. E, I, and A. E, element, I, index, A, array. I don't know. What's a couple extra characters to type? Right? So this is exactly the same as when I had the function all written out. Function, I said const, positive number equals, element, arrow, return, blah, blah, blah. This is, what I'm trying to show you is the most compact version of this code. So we're doing longer steps to shorter steps. So let's use this and do reduce. So if I say positive numbers reduce, so reduce is going to take a reduction formula. So let's do a sums numbers. So it's going to take a function that's a const sums numbers is a function that's going to take a total and an element. And it's going to return total plus element. So the idea of, oh, and this also takes a initializer. So the idea of reduce is reduce function takes two things: a function to call each time and a start, the starting value. So we're saying that total is going to start out as 0. So the first argument to a reduce function is the current counter. It's the current, what we call the accumulator. That's going to be 0. And it's going to take the first element of the array, add that to total, and whatever the answer of this is becomes the new total the second time we're called, and the element. Then we add that to the total, and then total comes back around into here. Now I get the third element. The third element plus the total so far comes back around into total, blah, 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 blah. Reduce is the hardest one to understand. It will take you months to be able to feel comfortable with it.
You don't have to set a length on that. It'll only just go through each element and then stop.
Yep, reduce, for each, filter, map, all of those run through every element of the array.
That's awesome.
Right? So this is going to give me back something. What it's going to give me back, oh, sorry, I want to count. Total. Actually, you know what? I don't even have to reduce this one. Because I was going to do let counter equal to this. But I don't even have to do a reduce for this because it's just the length of this array. Right? The number of positive numbers is just the length of the array. Oh, it's even easier than that. Right? So let's see if just taking the length of the positive numbers gives us our answer. Holy shit, it does.
Previously defined let positive numbers equals input. Okay.
Because I filtered down that array into just the number of positive numbers. Now for this one, I do need the reducer. Right? So now I have to say, because I'm totaling negative numbers reduce sums numbers. I take a 0. Oh, thank you. Reduce. Now let's make a sums numbers function that takes a total and an element and returns total plus element. Right? Trust me, reduce is hard to understand. It takes people a long time to figure it out. It just does. And this is going to become our sum. And we don't need this one anymore.
So the comma 0, so will you explain those two
Yep.
sums, numbers, and then the comma 0?
So reduce takes two things.
Okay.
The function to call and the beginning accumulator.
And the function that you're calling is the constant sum numbers above.
Yes.
Okay.
So whatever this second value is becomes the first input to total.
The initializer.
The initializer, and then element is the first element in the array. Whatever this returns becomes the next total. And this becomes the second element in the array. Then we add that to total, and that becomes the next input to total. This is the third element in the array. Right?
And it just continues to do that.
And just continue to do that all the way through the entire array. Right? And if that turns out to be right, this is cool. So, right, we can apply our,
That element is talking about the array that's below.
because that is the contract of the reduce function. If you read the documentation of reduce says, for every element of the array, I will call your function and give you two things. The first thing I will give you, the first argument will be your accumulator, and the second argument will be the current element of the array. The same contract as for each.
It's like
For-
adding the 14 to a 0 and then a 15
Yeah.
to 14.
Right.
And then, so
Right? For each is this, of all of these functions, for each, filter, map, and reduce, for each is the simplest. Don't worry about understanding filter or reduce or map until you've nailed for each. Nail for each. Like when for each becomes like, man, I got this. Like I can do for eaches all day long. Then go figure out filter. Then go figure out map. When you got filter and map down, go learn reduce. That's the order. Don't necessarily worry about these. Just know that the pattern is similar. Once you've got for each, you'll know that for each takes a function, and that function takes an element. And it's going to give me every element of an array, one at a time, every time it calls my function. Once for each becomes like muscle memory for you, filter and map will be easy to understand. If you're trying to understand them all at once, it's going to be a little bit harder to get, right? You're going to get confused. So like nail down, like do a bunch of practices with for each.
So in this example, the element that is going in there right now would be like -11. That is like, or it would be 0 and then -11.
Right.
Technically,
Yeah.
You're going for the negative numbers right now.
Yeah. So it would be yeah. Total would be 0. Element would be -11.
Okay. Okay.
Then the second time it's called, total will be -11, and element will be -12.
And
The
then
next time-
returning it is the, okay.
Yeah, so
This
that will be
makes a little more sense.
-23, and element will be -13, which will become -36, right?
And this is just like, this is exclusive to reduce right now.
Yep.
Just this one part we're talking
Mhm.
about. Okay.
So let's apply this reduction rule, and then what is your question? Right, so this is the same reduction rule. Question? Okay, cool. So here's our next reduction rule. So instead of declaring this variable, we'll just put it right here. All right. Right, here's the next reduction rule. I'm only using this variable one time, so let's put that here. And I'm only using this variable one time. Let's put that there. I'm only using this one time. Let's put that there. I'm only using this one place. Let's put that there.
Wouldn't you want to save that though for future numbers?
Yeah, but if I'm playing the like, get down to one line of code game, right? Right. And I still believe this is one line of code, although I'll format it like this. Right. Right. That's where you're going to get eventually. That's the final, like, oh man. And you're right, I would probably, if I were really writing this, I would probably stop somewhere around maybe here.
Because you want to be able to call positive numbers.
I don't need to.
Yeah, but if you had a larger program.
If I had a large, I would actually stop here just to make it readable.
Right, that's what I was thinking.
I would just stop it here to make it readable. I think this is the shortest yet still readable lines of code. If I'm playing code golf, right, I'm trying to get it down to one line of code, I would continue to do that.
But you'd still start with the steps like this.
Mm-hmm. And I would, and what's going to happen is as you practice these and as you code more, your brain is going to be able to go through those early steps quicker. You're going to be able to look at a problem like this and say, aha, there's two things, a count of positives and a sum of negatives. I'm separating things into two categories. That's filter. Cool. So I know that I'm going to take my input and filter it based on some filter function. Cool, I get back two different arrays. One array I can just count the elements. The other array I need to sum. Sum is a reduction. I'll just make a little reduce function, right? And that will happen to you in the first 20 seconds you look at this, after you've been practicing these for probably a year.
At least.
Right, right,
Master for each first.
right. Master for each first, right? And eventually, like, you'll drive to here, right? But this is taking the problem, breaking it down. See how many small steps I went through? Like, looking at this problem, I could just write this. Like, I can read that problem and write this and be done with it, right? Because my brain has done the for each loops and counting and whatnot tens of thousands of times. And I know when I look at this problem, I can immediately tell this is a filter and reduce problem, right? Because I've done dozens of these. And you will start to see patterns in problems that lend themselves towards different patterns of code. In the beginning, you literally have to go back to that like original documentation that I did that is all of the steps. And I guarantee you, if I was starting this and I ran into an error, right, like I did when we forgot the null and the this, what did I do? I went back and I wrote those steps, and then I wrote the code, right? The bigger the buzzsaw I run into, the harder I go back and write smaller steps. If I run into a little buzzsaw, I write a little bit of steps and then write the code, right? I run into a big one like, oh my God, my understanding of this problem was totally wrong. I'm getting not even the right answers. Okay, I need to go back and make smaller steps. Cool.
It's very time consuming.
Hmm?
It's very time
Yeah. You spend more time as a programmer thinking than you do typing. Right? Like, I joke that I get paid to type. I do not get paid to type. Mm-mm. All of what I get paid for is up here, right? I get paid to stand at the whiteboard. I get paid to like write on paper, right? Like the final bit is me sitting down at the keyboard. That is the byproduct of the actual work.
I had two questions, but so if you were typing like all this, including stuff that's in the sample tests, would the stuff that's in the sample test be what's in your main and everything else is above it? Is that
Kind of. What Codewars is doing is the idea of you have tests that is your production code, your code that's going to be on Surge, your code that people are going to use. And then there's a whole body of code in every project that is the test code that is used by developers and the testers and the test system that does not go to the production server, right? So if the business we were was a counting positives and summing negatives business, like that's what our, gotta count positives, sum negatives.com and give us some arrays, we'll give you some counts and sums, right? This is the code that we would put up on the server and deploy to Amazon and,
Now I know
right?
capstone.
Right? There you go. Right? But this code down here, we would hold back. We would not, this is not part of what goes to the website, to the app. This is code that we write to see if the code we wrote is actually correct. So these tend to live in separate files, even separate directories of our application. This code is over in the app directory, public, right? This code usually goes in like a test folder.
But the solution definitely does rely on sample tests, like just because it's drawing the numbers from that.
The sample tests are driving this code. The sample tests are like, okay, cool, Gavin, you wrote count positives, sum negatives. Let me see if you are right. Right. So the way we would do it is, remember, like you were the filter and these guys were the array, right? Right. Then what would happen is there'd be a whole other room of people that they would send in an array. Like, all right, here's an array. Room, you go figure out what the answer is and tell us, and we'll go thumbs up or thumbs down. That code that's in the other room that's calling us and saying, here's an array, give me 2 answers, that's our test code, right? It's giving us a whole bunch of different kinds of input, and it's expecting us to give it some output, and it's checking to see if we're right or wrong, right? So, right, whoever wrote this test code had to come up with 10 and minus 65 manually. And then for this array, they had to come up with 8 and negative 50 manually. So somewhere in this attempt, someone wrote a whole pile of tests that give us a whole pile of inputs, and one at a time sees if we get the right output. Right? Remember when Jim said, right, practice testing? Right? That's this. Right? It's not enough to be able to write this code. Eventually, what you're going to be asked to do is write this code and write tests that make sure your code is correct. It's not enough just to write the code. You also have to have code that you know makes this work, right? Because what if I changed this to use filter and I didn't have tests? How would I know if my code was correct? How often are you like reloading your weather page to see if the weather in Chicago or Tampa, wherever, is correct? What if there was code that could do that for you? Right, and all you would do is press enter. Like every time you hit save, it told you whether or not your website was doing the right thing. Wouldn't that be awesome?
Yes.
Right? That's the whole idea of those automated tests that Jim was talking about. Right? So we expose you to testing through Codewars. We'll do a day or so of like showing you how to write tests. The problem with this is like your brains right now are just like on fire, just trying to understand how to write this code. Trying to get you to write code that tests code is like a whole nother level of inception that like, if we drive that on you too, like this will pop out, right? Like Jason was talking about like the flashlight, right? What will happen is as soon as you turn that light on and your whole room is illuminated, we will reveal to you that there's a whole other room outside of that that's the tests, right? And then that whole room will go poof.
You're right.
Right. So we want you to be able to write code because guess what? How do you get test code? You write code for test code. So we got to get you good to this.
Just to be clear, input is an array. If we were putting this in our code, we would have to say input equals array of 10, 12, negative 8,
Yeah.
15, 12.
So,
then we could call it.
Yeah, if we were putting this in an app, right? Somewhere we would have code like this. Oh, look, empty spaces. I hate empty trailing spaces. right? Then somewhere we would have like our main, and we would say let array 1 equal to 1, comma 2, comma 3, comma 4, comma -1, -2. And then we would say, it would say let answer equal count positive numbers array 1, console log answer, right? Count.js, right? Node is a little like terminal side thing that can run JavaScript, right?
You get back to that first.
Right. This is the same code. Here's I'm just calling it, right? This is how I would use this code, right? And I got the right answer. I got 4 and -3, right? 4 of these, and then -1 plus -2 is -3.
Because of what you have up here.
Right? So if this was like our old friend app, right, we would have like const main equals, right? Right. Document.query event listener query, wait, document add event listener. Right, DOM content loaded, comma main. Right? That's what this would look like if we took this function and we put it inside of an app. Right? Wait for the DOM to be loaded, call main, main makes a little array, it calls our little function, and console logs the answer. Right? If I wrap this up inside of an app, right, the code page would load, and in the console it would put 4 and -3. Right? So in Codewars, we're just writing the code part of it, and Codewars has got its way of running our code and running the test code somewhere in the bowels of their super slow servers. That happens, right? Right. But the equivalent here is, right, this is like your go fetch the weather function. This is like your play blackjack function, right? The way you launch it is different here because we're on a web page and we're waiting for DOM content to be loaded, and we call this function, and then work happens. In Codewars, we submit our code to them, and they run it however they run it.
Where's array 1 defined in the back? Okay. And then count the sum. Okay.
It's just our function. All I did was I took our function from Codewars and made a little function that called it, right? So if I change this, say this is answer 1, and this is answer 1. If I copy and paste this, let's use the actual arrays from Codewars. Let's grab this one and paste it here. Let's make this array 2, and array 2, and answer 2, answer 2. And let's take this array and copy and paste it here, right? So here's, and if I, what do I call this? Count.js. Oh, we don't have document event listener here, so I'm just going to call main because we ain't on the web.
What is main?
Main is this function. Main is the same main function y'all have been maining for 3 weeks now, right? But I don't have document event listener on my terminal, so I just have to call main. Hey, and look, we get 10 and -65 and 8 and -50. Isn't that what this was expecting? Right? So could I write a little test here that says, hey, you know, if answer 1 is, what was it, 10 and -65, then say good job, right? That's exactly what this test is doing. Green or red, based on whether or not when you call this array, do you get the answer you expect. When you call it with this array, do you get the answer you expect. That's all that test code is doing, right? In a fancy language that does all the coloring and whatnot and blah, 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 right? But all it's doing is saying, set up an array, call your function, check the answer. Did you get what I expect? Yes, green, no, red.
So writing a test is pretty much just putting random variables in the function that you use.
You're giving it input and expecting output, right? So sometimes you give it expected input, right? You make up your own input. You as a human being compute the answer and call it. And then there's other ways of testing it as well.
Would you mind going back to your code really quickly?
Let's go here. Oh, wait.
Or within
Let's go here.
Yeah. So just really quickly, the let answer 1, let answer 2 thing. So you have equals and then the count, positives and negatives. So the second part of it, the array, that's so you just like define that like really. It's like count positive, some negatives, and then like array 1.
Yeah.
So
array 1 here is my array,
yeah.
right? This array is showing up here into this array 1, and then it becomes input, right? So, oops. We're setting array 1 to be this array. So now JavaScript knows when you say array 1, you mean this array. Then we're telling, hey, go count the positives, some negatives, go do this function. What should you give it? Give it whatever's inside of array 1. What's inside of array 1? All of this.
What are those two parts called? The count positives.
This is the function to call.
Yeah.
This is the first argument.
Okay, it's a function argument.
Yeah,
Okay.
this is the function, then the first argument. If there were more arguments, the second, third, fourth, and fifth argument. Array 1 up here becomes input. So inside this function, when we call it the first time, input is actually all of this. If we ask JavaScript inside of this, hey JavaScript, what's inside of input? It would tell us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 11, so forth.
How does map differ from filter and reduce?
So map takes an input array and returns a new array with every function transformed into a new value. If you give it 10 items, you get back 10 items. Each item has been changed by the function that you give map. Filter takes your array of however many items and gives you back the same number of elements or smaller, where the function tells you whether or not you should keep an element or not. Reduce takes your entire array and shrinks it down to one value based on whatever the reduce function returns. Map, filter, reduce, right? So if you think about the problem and you say, I need this array, but I need it differently, I need to take every element and change it, you need to reach for map. If you're like, hey, I need to take this array and I only need some of the values from it, a few of them, that's filter. If you're taking the big array and you're squishing it down into one answer, that might be reduce. Just remember that reduce tends to be the hardest one to use. It's the one that's used the least often, right? For each, map and filter are probably used 99.5% of the time, and 0.5% of the time we use reduce. Just because the style of reduce is like hard to keep in your head, and the syntax can get kind of tricky for anything more than a very simple like sum kind of function. So focus on for each, map, and filter, and then like if you get to play with reduce, awesome. But master those three, like, and start to use them in the Codewars you do.
Is it okay to write for loops and then go back and go, okay, no, that's a forEach, let me make that forEach now. But if I get it work before, because I understand for really well.
If you can do a for loop, keep writing for loops, right? But every time you finish writing a for loop, go back and ask yourself, could I have done this with forEach? And then once you're done with forEach, you can ask yourself, hey, does this forEach, is the work that it does like filtering down an array? If so, maybe I'll try and use filter. Hey, is it turning one array into another array? Maybe instead of forEach, I want to use map, right? So it's steps on the ladder, right? If I can write a for loop in the beginning, awesome, right? I'm just going to keep writing for loops until that becomes muscle memory, and then I'm going to look at those and go, all right, I've done that enough now. Can I look at the forEach that I wrote, for loop that I wrote, and turn it into a forEach? Then I'm going to like write forEaches until I get sick and tired of those, and then I'm going to start looking at my forEaches and go, oh yeah, but you know what? This forEach is filtering. This forEach is mapping. Now I'm just going to rewrite those as filters and maps. Right? And then you'll get to the point where you can look at a problem and go, oh, this is just taking a couple of arrays and filtering them and mapping them and reducing them a certain way, and then I'm done. But in the beginning, it's literally that whole long process of the instructions and turning into code, right? And going step by step. Often what I see from you all, and this even goes to the homework, is like, you're working on something and then you run into a wall, right? And the natural tendency is like push through the wall. The maximum learning comes from actually stepping back and saying, I ran into a wall, let me think through what I was doing into more steps, so that each of those steps I avoid running into a wall, right? So that running into that wall is actually positive, it's a positive feedback loop. It's actually kind of, it's negative, but if you take it as a positive, it's telling you that you did not think through the problem in enough detail. And what you need to do is take a step back and go spend 5-10 minutes breaking down whatever part you ran into the roadblock with into more steps. right? And if you then go through each of those steps and you run into a roadblock again, right, you run into a wall again, take that step and break it down.
So my question is, because sometimes this has happened to us where we've gotten to that point where we're trying to break it down, and we get to a point of we literally have no idea. Like, what are we doing?
In order to break it down?
Right.
Right? So that's where, like, you try and go through the problem in detail, right? So this is where, like, the PDAC stuff comes into play, which is where you try to, right, come up with examples and test cases. So I think if you start to, like, hey, we how to sample data, see on pen and paper how to do it, right? If you can work on pen and paper how to do it, you do instinctively know how. That is the time where you have to, like, all right, I need to reflect on, like, what is it that my brain is doing automatically that I cannot express in words, right? It's like asking, like, if you asked a professional baseball player, like, how do they hit the ball? They cannot tell you in words how they do that, right? They've just learned over a long time how to do it. That's what you're actually trying to do. Like, how do I say, right, I hold the bat here with this much tension at this angle. I watch the ball come in, and if the ball's doing this, my bat's going to do this, right? It's trying to break down problems like that to small details. And the only way you can do it is with practice and then literally trying to go through examples, right? So if you're like, I don't know how to proceed, pick up an example and see if you can do it by hand, right? That gets a little more challenging when the problem is like, click on a button and do a thing, right? Or it's like, go through this JSON object and get the weather back out, right? There what you have to do is like, some people work really well on paper, like print out the JSON, literally print, or like go to the whiteboard and write out the JSON and say, how would I navigate this? Well, my eye first went to here, and then my eye scanned down to here, and then I saw there was an array, and I went through each thing one at a time. Okay, well, how do I explain in code my eye went to here? Oh, that's the dot notation. How does my eye go through an array? That's a forEach, right? Even if you can write out the details of that, what will happen is the more times you do that, right, and we help you through the how do you then translate that to code, you'll be able to solve problems and do that translation better. So at this point, it's like it's running into that wall, trying to break it down as best you can, and then coming to ask me or Mark or Jason, how do I break this down more? And maybe we'll tell you, no, you're at the point where you just do code, or yeah, break this down a couple more times. Here's the next level of breakdown. You go do one more level.
The panic sets in. Like yesterday,
Right.
when we were trying to make a class, we didn't really understand what we were supposed to even do. I was like, I don't even know what to do at
Right.
all. So it was hard to even write steps down of how I'm going to do something if I genuinely don't even know.
Mm-hmm.
That's why I had to come ask, because I'm going,
Right.
I don't really know what to even do. I can
Yep.
work on a problem if I know what's the problem.
Right, right. And the challenge is like most of the time when you're working on stuff, the requirements are not going to be clear. 90% of the time, you're going to get assignments like go do the thing with the thing.
Right.
Right.
That's so
Go make the website work. Hey, go make the input work so when people sign up to be interested in the Iron Yard, the data goes somewhere. Like that's probably the instructions Jason gave Tony. Jason, go make the website so when people sign up and they're interested in the Iron Yard, I can track them and call them on the phone. Okay, well, what information? How's it supposed to work? Well, I don't know. Just make it work. Right?
So it's up to you.
Do the thing with the thing.
It's up to you.
Yeah, it's up to you to like pull that stuff out of the problem, and then you start breaking it down. And then when you get to a gap of like, I don't know what to do here, maybe you're missing some input. Right? Maybe you're missing some context. Go back and ask for context. Right? That's when you're coming to ask questions.
Right.
And then we talk about it, and we figure out how you're going to solve that problem different than how he's going to solve that problem. And your steps to break it down might be different than his because you're breaking the problem down differently. So I think we covered algorithm translating and for each map filter reduce, Codewars. We talked a little bit about the structure of the code, but maybe not enough. Let's talk about classes and passing data. Let's do that with a class. Let's make a class. Let's make a class called a number classifier. I don't use the word class again. Number separator. Separator, which is right.
That one.
Is that one right?
That one, yeah.
Okay. So here's what our number separator is going to do. I want a class that can accept an array of integers, array of numbers, and give me back the positive ones and the negative ones. Surprise, separately. That's what I want this to be able to do. Right? I want a class that can accept an array of numbers and give me back the positive ones and the negative ones. Kind of like I want a class that can take the JSON response from OpenWeather API and give me back the humidity, the temperature, the max temperature, the conditions, right? Similar kind of things. I want a class that takes one thing and can give me back other things. So we're going to define a class called number separator. And since the class takes something in, that means we have a constructor. What's our constructor going to take? Numbers. Cool. What are the two behaviors of our class?
They're going to be positive or negative.
Yeah, so give me positives and give me negatives. Do those two behaviors need anything other than the numbers we gave the class? Do those two behaviors need more information? No. So those two behaviors, those two functions, are not going to take any arguments. Right? They have enough on their own. So the class has to remember information. Right? We're going to be given information from the outside world, and then it's up to the class to like hold on to whatever it needs. Right? Right? You know, ever see the Daffy Duck cartoon? All the clams in Pismo Beach, they're mine, they're mine. Right? He's going to hold on to all of those things. Right? So we're given an array of numbers from the outside world in our constructor. That's how information gets into a class. It's up to us to determine what we need to keep. The way we keep things is we assign an attribute. Let's call it our numbers. So in the constructor, we say our numbers is a copy of the numbers they gave us. So we're saying in the constructor, hey class, you need to remember this information. It's important. Hold on to this. We need this. Keep a copy. Right? Yeah, like we might pass in the JSON into our weather API information class.
This
Right?
is like a defined part of this always, right?
Yeah.
Yeah.
Yeah. Called when we make a new instance of this class. Right? So this constructor is going to get called when we make a new instance of this class. So the give me positives, right? We kind of did this, right? So let's do it the long way. Let positives be an empty array. For let index equals 0, index is less than our array length, index plus plus. Where does our array live now?
Oh, where does it live?
Yeah. No. Our numbers. We, the class, saved into this our numbers. Right? We know, like, anytime we want to access our own information, it's this dot something. If we, the class, own the information, it's this dot something, our numbers. That's where we saved our numbers. Right? So let's say let element equal this dot our numbers index. If the element is more than 0, right? Let's add that element to the end of the positives. Otherwise nothing, return positives. Right? Start with an empty array, kind of like starting with 0, like we're totaling.
Null we did. Is that like the null we did?
This is like the filter that we did before. Oops. This looks like a filter.
I was
Right.
trying to turn it into a forEach.
Right. So here's our positives. Let's see how we would call this. We haven't finished the negatives. Right. So let an array equal to 0, minus 1, 2, minus 3, 4, minus 5. Let's make a new classifier. What do I call it? Separator. New number separator, and we're going to pass it something. What does our constructor require?
Numbers.
Numbers, an array of numbers.
Array 1.
So that's array 1. So if I want to get the positives back out, I'm going to ask the separator, please give me the positives. And I'll console log the positives
Where is separated defined?
right here.
Oh,
This is the numbers we want to separate. Make a new instance of the number separator and give it the numbers to work on. Ask that instance for the positives. Log them. Right? We make some input. We give that input to the class. We make a new one that gives us this object. And then we can ask that object for any of its behavior. If we run this, oops, what directory am I in here? If I run this, wait, how did this directory? Oh, I called it class. Oops. Why did I not get back? Oh, our number's length. Right. I want to keep going as long as the index is less than the length of our numbers when I get back 2 and 4. Right. So let's rewrite this using a forEach loop. This dot our numbers for each number if number greater than 0, positives push element. Finally, return positives. This is just turning this into a forEach loop with a function inside.
And you left the for loop up top, right?
And I just commented that one out.
Thank you.
Oops, and this is push number. 2 and 4. Now let's write it with filter. Oops. Let positives equal to this dot our numbers filter every element. Return if this number is greater than 0. Here it is as a filter. So I'm saying our numbers filter for every element ask, is that number bigger than 0? If it is, it's in the positives. Oh, this is number 2 and 4. Let's slim it down.
Right, I was going to say there was a way because of the arrow.
Right. So the first thing is I can just return this. And then, right, I don't need the brackets. I don't need the return statement. I can put these all on one line. Here's what I'm looking for.
So you turn the forEach into a code.
I turned a long for loop into a forEach, and I turned the forEach into a filter. I turned the filter into a one-liner. So let's do the negatives. Well, guess what? And we're done.
Change the creator then.
Yep. So
But now you have to call it down there and give them negative numbers.
here's the 1, 3s, and the 5s. So imagine this was our weather API, right? And you get this big blob of JSON, right? What you want out is I want the current weather. I want today's weather. I want the forecast. I want this. I want it back in specific units. I want it formatted as a nice string. If you give your weather API the big JSON, then you just have little behaviors that give you back the things you want, right? The whole idea is I have now abstracted the idea of how do I separate numbers into positive negatives into one class, right? If your API or your buddy or your boss, right, gave you this class, this is the code you would write. I don't even have to worry about how he does it. Maybe he uses an API. Maybe there's a Google API that's called a number separator. He's using fetch to go off and do that. I don't know. Maybe he's using filter. Maybe he's using forEach or for. I don't know. All I know is that if I give number separator an array and ask for the positives, I'm guaranteed it's going to give back the positives. Just like if I had written a weather API class for you and said, if you give me JSON, I will give you back today's weather. Way easier than you having to worry about how all that works. It's also cleaner than sticking that code randomly throughout your code. All of the logic for how to deal with that JSON is nicely hidden away behind the wall of this class.
So what would you put in the class? You'd be class, JSON, weather.
Yeah, class, weather API. Maybe it would take a constructor that takes JSON and has a this.json as JSON.
In lowercase j.
Yeah, and a lowercase j. Or be consistent, right?
Keep the data somewhere else. So
Mhm.
put the constructor JSON in Node, you can go down to wherever that is and find that file.
Yeah, all I'm saying here in the weather API is the contract of the weather API is if you give me JSON, I will be able to pick that apart and give you the things you need. Somebody else is responsible for doing the fetching and actually getting the JSON and handing it off to the weather
Because you're
API.
putting that class down where you did the fetch, it knows that that's JSON and that's what we're going to do.
Right, so maybe this says return json.main.temp, right? And the humidity is return json.main.humidity, right? But maybe like average forecast, average temp this week, right? So maybe somewhere in there is the temperatures for every day. So maybe you say let total temp this week is json.forecast dot reduce. It's going to take a total and a temp, and that's going to return. We're going to do a little adder here. Total plus temp, and then finally divide by JSON forecast length. Right? That's an average.
JSON is the actual API.
Is the JSON results. It's the JSON object that comes back from the API.
And I assume you can put multiple URLs to fetch different data. in all
Yep.
those.
And I would have,
The same.
I would fetch, get back JSON, give that to the weather API, store one of those objects. Fetch, get back JSON, make another object, and I would have two different weather API objects. One that's processing the JSON for Chicago, and one that's processing the JSON for Tampa.
So does that API key actually stay in the main?
So you're going to do the fetch in one place, and you're going to hand off the results to the weather API. So if that's where the key is needed, that's where the key stays. Right? The key is just needed to build the URL. The JSON is the response that comes back from the API. Right? The contract between your code and the API is if you send me a good URL that says you've got an API key and you've got city as Tampa, I will give you back JSON. Then you're saying, cool, I got JSON back. I'll make a contract with this class, and if I give him JSON, he will give me back the average temperature this week. He will give me back the humidity. He will give me back the temperature. Right? It's goes into's and goes out of's. Right? The goes into the API is the name of the city or the zip code and your API key. The goes out is out of that. Comes out is JSON. JSON goes into your class. What comes out of your class? Temperature, humidity, and average temperature. Right? Now you could do all that code in a row, right? And that's probably how you started, right?
Yeah.
Get the JSON back, pull this variable out, put it into a thing, add an li, do a thing, blah, 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 blah. But if all of a sudden you start doing computations in there, and you're forecasting the weather, and you're doing averages, right? All this code is mixed together, right? The code to pluck out the things out of the JSON is mixed with code that adds it to the DOM, which is mixed with code that computes things, right? This starts to organize the code into responsibilities. The responsibility of the weather API class is to take JSON and give you back the temperature, the humidity, and the average temps this week. If the structure of the JSON changes, you have one place in the code to change that. Nobody else has to worry about that. What if you used that code on 6 different web pages? And they said, hey guys, we're changing the API. Main isn't called main anymore, it's called today. Really? Okay, I gotta go to every file and find where I use json.main and replace it. If you were using the weather API and they said, hey, main has been changed to today, I change it in 2 places and every other bit of code remains unchanged. Because they said, I'm just gonna pass you the JSON and it's your responsibility to give me back the humidity. Right? Everywhere else in the code, I have things like weather equals weather API new JSON weather API dot humidity. It doesn't talk about JSON dot main all over the code. Only in one place does it deal with that. That's the idea of classes. So when you're like, hey, how am I gonna use a class? As soon as you have data and behavior, you have a class. I have JSON and I'm pulling things out of JSON. That's a class. I have JSON and I'm computing the average temperature for the week. That's data and behavior, that's a class. All right, so as soon as you have data and you're doing some work on the data, that's a potential to have that be a class. Does it make sense for everything to be that way? Maybe not. But as soon as you have like 2 or 3 things, I'm getting the temperature, I'm getting the humidity, I'm getting the name of the city, I'm getting multiple icons to show on the screen, boy, that starts to sound like a lot of behavior and some data. That's when we make a class, right? So this is like the next level up from like, okay, I've got my functions, right? Now it's how do I organize these things into a tidy universe of things.
So say you want to use that, like say every app I make, I want to display the local temperature. I could make that into a file and call temperature on every single app.
Yep, you could package that up and use it in every one of your apps. I could take this weather API and use it in every app that I'm doing. And then if all of a sudden the weather API changes and it's not called .main.temp anymore, I make one change and all my apps keep working. If I didn't do this and I copied that code into every one of those apps, I have to visit every one of those apps and change them, right? So this is the idea. You'll hear programmers talk about the DRY principle, D-R-Y, don't repeat yourself, right? The idea behind don't repeat yourself is that you want one place in your code where a particular type of logic is done. There's one place in the code where we pull out the temperature. There's one place in the code where we pull out the humidity. There's one place in the code where we calculate the average temperatures that week. Right? If I do that in multiple apps or multiple pages, I don't want that code repeated in each of those apps or each of those pages. So I'm going to don't repeat myself by making a class to encapsulate that logic, that data and behavior into one place.
What do you call temperature in the event listener in the main?
You could, yeah. And as long as you have the JSON and you pass the JSON to the weather API, then you can ask the weather API, give me back the temperature.
So if you were to do it right there. Oh, well, that's not.
Yeah, I don't have all that code there, right? But this would be somewhere there would be a main that does an add event listener for a button click. That's going to call fetch. That has those two thens. Then finally JSON. Then you would call weather API. Then you could call temperature.
Why do thens?
Because the first then gives you back the response. And the second then gives you back JSON. All right, remember fetch, URL, then response, return, response JSON. Dot then JSON arrow. Now I can work with JSON. Those are the two thens.
Whatever the JSON's called.
I called it JSON. Right, I could have called it Taco Tuesday or Taco JSON. Right, but there it is. Right? Cool. I hope this